So I taught the office the components of a combustion reaction. Let's see if they remember any of it. Yeah, what's that smell? Smells like
fire! There's a fire in the room! Fire! Attention, everyone, fire! There's a fire in the laboratory!
What is going on?
A fire! Small elements of fire have been detected!
Oh my god, what is that?
No, fire!
Oh my goodness, I'm getting a little dizzy. Oh my god,
Attention! The fire was merely this candle, everyone. There is no more danger.
I could have died because of all that carbon monoxide. Stupid Dwight.
So this is what they should have known. The paraffin only needed the oxygen to continue burning. So you just have to take out one of the reactants, which I did with oxygen.
I am so disappointed in the lab today. I feel like I should start demoting people, but how can I do it without breaking their hearts?
Hold on, boy. What you doing with? I'm listening to my FM radio station.
But Stanley, I want to listen to Radio Disney.
None of that AM crap. Boy. FM is better.
Nuh-uh. AM is way better.
AM wavelength's better than FM wavelength? False. This calls for a hands-on race. Here are the rules of the game. Stanley, you represent FM wavelength, so you have higher frequency and shorter wavelength. And Kevin, you're AM, so you have shorter frequency and a longer wavelength. Wavelengths on your mark. Set. Oh. Hold up. Stop there, Stanley.
Well, what's the problem, Dwight?
You cannot go faster. You guys must go the same speed.
But why?
That's just the rules of the game. Everyone travels at the speed of light.
I still don't understand why we have to go the same pace if we're doing a race.
Well, you, AM, and FM are in the electromagnetic radiation, which all have the exact same speed of light, c. Although your wavelengths may be shorter or longer, although your frequency may be higher or lower, you all will have the same speed. None of y'all will win.
Well, I knew AM could never be FM.
Whatever, Stanley. I still like Justin Bieber.
Who is Justin Bieber?
I'm hungry. But I'm on a diet. Let me see how many calories there are in this.
to this equation of photosynthesis, for every mole of glucose produced, 700 calories are used. Usually, a chocolate bar is 45 grams, and in a mole of glucose, it is 180 grams. So 45 is 1/4 of 180. If you multiply everything by 1/4, you get 175 calories. Am I right? What? How come there are 200 calories? How is this possible?
Well, Kevin, you see, chocolate bars contain a lot of fat, and you are only using glucose in your equation. But fat is more dense than glucose, so it should come to be around 200 calories. It's okay, Kevin.
Hey guys, to get into the holiday spirit, we will be playing a little game. Each of you will get stockings, and as Santa, I will put in coal for the naughty people. And that also means that you'll get demoted. Okay, bye.
So I found this paper on Michael's desk, which means he must be treating this demotion thing like a redox reaction. So far I've already solved this redox reaction. First, if you use the redox rules, oxygen should usually be -2 here and here. So that would mean that the iodine would have to have a redox number of +5, so the net charge would be 0. Same here, carbon has to be +2 for a net charge of 0, and carbon has to be +4 here for a net charge of 0. And since iodine's all alone, its redox number is 0 as well. If you look at the oxidation numbers, iodine was reduced 10, and carbon was increased 10. Now I saw somewhere that Phyllis was actually iodine, so that would mean she's getting reduced or demoted. And Stanley was oxygen, so he didn't increase or decrease anything, which means, so if someone's getting demoted and someone's just nothing, then who's getting promoted? Me.
Hey Stanley, want to go look at our stockings?
Why not? Look at that, girl. Ain't got nothing in here. Whatevs.
Oh, what? I got coal. Does this mean I got demoted? It's alright, Phyllis. I got something to cheer you up with.
Okay.
MGO!
Oh!
Look at this.
Wow, so bright.
It's kind of getting hot. Guys, what do I do now?
Oh my
What do I
God.
do with this?
Oh my God, put it in here, Michael, put in the water!
No! Don't do it! My Professor Plumbum once did, and...
Michael, you've done it now!
Oh my gosh, I keep seeing all these bright lights. I shouldn't have looked directly into the MGO.
Alright everyone, down to the basement now.
Well, I thought it was pretty impressive. I mean, it's just a simple combustion equation, really. You just light some magnesium on fire, and it reacts with the oxygen in the air, and what do you know? Get MGO.
Could I add something? You see, this was also a simple redox reaction. If you write in the oxidation numbers, the magnesium first is 0, oxygen 0, but when they're together, the magnesium's +2 because it oxidized and the oxygen was reduced. 4, 7, 1, 6, 2, 3, 2, 5, 6, 5, 9, 3,
Hey,
7,
Dwight,
4,
what
9,
are you
3,
doing?
8, 2. Sudoku.
Oh my god, there's so many numbers. I can't do with this
Sudoku. Oh my goodness. Oh goodness, Dwight. Can we do some easier math, like adding equations?
Hey Phyllis, you got anything to eat?
No, but I do have this equation of respiration that involves eating. C6H12O6 plus 6O2 yields 6CO2 plus 6H2O. And over here, delta H is shown formally, and by breaking down glucose, we are absorbing 700 calories. False. Delta H is not positive, Phyllis. If you look at the equation here without delta H formally, 700 is a product, and so it's on the right side of the equation. That means delta H should be negative because the heat is being released from the reaction. Oh, I'm getting all heated up. Cracky!
Guys, I'm hungry again.
Well, all we have right now here in this basement is a bowl of cup noodle, 500 milliliters of water, a candle, and a butane C4H10 lighter.
Well, it says here that we need to get the water to 100 degrees Celsius, which is the boiling point. But how are we supposed to get the water to get that hot?
Boy, don't you know any better? Haven't your mama taught you? All you have to do is use the delta H equals Cm delta T equation. You see, the specific heat of water is wonderful. What do you know? 1 calorie per gram degree Celsius. The mass is 500 grams, which is also 500 milliliters, and delta T, we want it to be 100 degrees, and it's 25 right now, room temperature, so that would be 75 degrees Celsius. So if you put in the equation here, you get delta H equals 37,500 small calories.
So now we can see how many grams of paraffin we need to burn to get that many calories.
Good job, Kevin.
Can we add some salt to this for some extra flavor?
Boy, don't you know one of the colligative properties of salt is to depress the freezing point and elevate the boiling point? I am ashamed. That means it'll take longer to heat up this water.
So I won't be able to eat the noodles sooner?
That's right, Kevin, so you better shush up.
Sitting in the hall with this chip in front of me. Call my man Dwight to talk more about chemistry.
Yo, Mike, this class is dope and tricky. Check out how we study in honors chemistry.
If you don't understand some of the material that you see, don't worry, you can just go to the CST. Chemistry.
What?
The art of chemistry. Chemistry.
What?
The art of chemistry.
Do you know the elements of the periodic table?
The noble gases are always stable.
A dangerous substance you ought to know
is sodium hydroxide, you know.
Never have fear of ice cold bears.
Are diatomic molecules, they come in pairs.
An atom consists of protons and electrons.
And electrons release energy as photons.
What is the point of this chemistry class?
So in college, we can kick some ass. Chemistry.
What?
The art of chemistry. Chemistry.
What?
The art of chemistry. Chemistry.
What?